Starting on page 1 of the review, and the first thing that I want you to write up at the top of this page is the things you will be expected to have memorized for the test tomorrow. The first is the Pythagorean theorem. So a squared plus b squared equals c squared, and this is a formula that helps us find the what of a right triangle. The sides, A, B, or C. C has to be the hypotenuse, but A and B could be either of the legs. The next formula that you need to have memorized is SOHCAHTOA. That's sine of an angle, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent of the angle, opposite over adjacent. Another thing that you need to be able to do and kind of have memorized is draw a general right triangle with all of the correct parts labeled. And I'll show you the type of problem that requires this so you can know what you should study for that memorized component. The last is your special triangle side shortcuts. So the S rad 3, 2S, S rad 2. So those are kind of our 4 main ideas of things that you may want to write up at the top of your test. And then it's trying to muscle your way through knowing when to do what. So looking at the first 2 problems, since we want to find sine, cosine, and tangent, we are going to be using SO, CA, and TOA. So for this section, we're not like solving for the angle. Third block had kind of asked about that. We're trying to determine the trig ratios themselves of opposite over hypotenuse, opposite over adjacent, etc. So let's go ahead and take a look at the first one. If I wanted to find sine of theta, we first start by marking the angle. So we got to make sure that we're looking at the right angle. Otherwise, opposite and adjacent will be different. So I'm going to go ahead and mark our theta on both number 1 and number 2, because that is the angle that's listed with those trig functions. So sine of theta would be opposite, OPP, over hypotenuse, which would be over here. That would make 3 the adjacent side. So what's our problem? We don't know what the hypotenuse is. How can we figure it out? Pythagorean theorem. And folks, in this section, I want you to have exact reduced fractions. So that means no decimals on that first section. We want simplified fractions, we want simplified radicals, and we want to make sure that we know which trig ratio goes with which of those trig words. Now on number 3 and 4, these are the 2 problems where you will need to draw a diagram. So draw a diagram for 3 and 4. And the diagram that we are going to draw is the general right triangle. So we've got one of our trig ratios that the sine of b is rad 13 over 7, but it's like, how do I use that to find the rest of the trig ratios? The best bet is to draw your general right triangle. So I don't care where you put the right angle. You can draw it like this. You can draw it with the right angle on the right side. You can draw it with the right angle above like we have down here. It doesn't matter how you draw the triangle. It's all about where you put the angles and the side labels. So the right angle is always angle C, and the side across from it is little c. And that corresponds to our hypotenuse, which is consistent with the Pythagorean theorem. A could go up here or down there, but the important thing is that angle A is across from side A, and angle B is across from side B. So I would put an important box around this because that is what our general right triangle is stated above. So on the test, I'll tell you to draw the general right triangle, and then we can use that to fill in the values that we know. So what we are given is sine of B. So that's the angle that we need to mark is B. So sine of B is rad 13 over 7. Well, sine is opposite over hypotenuse. That's the so part of SOHCAHTOA. So which side is opposite from angle B? Little b. So B is rad 13 as the opposite side. My hypotenuse side is C. So the first thing we are going to need to do is find out what A is, because A will be my adjacent side, and I'm definitely going to need that to find cosine. So Pythagorean theorem time, because we know 2 of the 3 sides. So A squared plus B squared, which is rad 13 squared, equals 7 squared. What's radical 13 times itself? 13. So A squared plus 13 equals 49. Subtract the 13. A squared equals 36. Square root. And A equals, normally we say plus or minus 6, but because we are solving for a side and it needs to be a positive value, we automatically leave it as positive. So A is 6. Super duper. So now we have all 3 sides, so we are ready to find our other trig ratios. So cosine is ca, or adjacent over hypotenuse. So my adjacent side to B is 6, and my hypotenuse side is 7. Can I reduce that fraction? No, we cannot. Throw a box around it. And then tangent is TOA, so opposite over adjacent, or rad 13 over 6. Is a radical on the top of the fraction okay? Yep, we just can't have radicals in the denominator. Any questions so far? How many of you like this unit? I'm just curious. It's better than logs. Let's go ahead and skedaddle on down to number 5 and 6. Oh, this pen is leaking super. Oh my gosh, it's all over me. Well, all right, folks, let's take a look at number 5. So it says completely solve each triangle. Completely solve means find everything. All the sides and all the angles. Oh my gosh, it's everywhere. So all the sides and all of the angles. So I normally start with the angle first, just because it's usually going to be the easiest thing to find. But folks, what I want you to notice about these diagrams is they're not labeled super well. On the next page, we are told what each of the angles are, so then I know that side A has to be over here, and side B has to be over there, which means this is C and that's C. But on this page, we're going to go ahead and put in some labels on the angles. That way, when you're checking on the answer key, all of our answers will match. So I want you to start by putting A as the angle on the right side, and B as the angle on the bottom. Then on number 6, B as the left angle, A as the right angle. And then on number 7, let's do B on the top and A on the bottom. That's just going to make checking a little bit easier for you, and on the test they will be labeled. So on these problems, instead of finding exact answers like we did above, we are going to be rounding our answers here. So on this section, we will round to the hundredths. And for consistency, and I will remind you about this on the test tomorrow, we want to find the smaller side first. So round to the hundredths and find the smaller side first. So as I mentioned, the easiest thing to find in this triangle currently is going to be angle B. Can anyone explain how we find angle B? Perfect. We're going to take 180, that's the total angles in the triangle, minus the 90-degree angle and minus the 7-degree angle. So you can show work for that if you want. That B will be equal to 180 minus 7 degrees minus the 90 degrees. And that gives us angle B as 83 degrees. And folks, help me out, and on your review and on your test, put a box around your answers for these so I can tell what goes with what problem. Next, now that we know B is 83 degrees, we want to try to find our missing sides, and there are 2 of them. Which side is across from angle B? Side B. And across from the right angle? Side C. Can I use the Pythagorean theorem on this problem? Not yet, because I only know one of the 3 sides. So for a problem like this, this is where we use our trig ratios for solving. So first we're going to mark an angle. Who's a better angle to use, 7 or 83? The 7, because that's a given angle. Just in case we're having a Monday and we goof on that, finding that 83-degree angle, I would always use your given information as much as possible. Same with the given side. What is 18 relative to 7? It is opposite. So then C is the hypotenuse and B is the adjacent side. So if we want to find the smaller side first, who's smaller, B or C? It's got to be B, because C is the hypotenuse, which is by definition the longest side. So we're going to start by trying to find B first. So using my given information, we've got 7, the angle, opposite side we know, and we're looking for the adjacent side. So we've got OA for our side relationship. So what are we going to use? Sine, cosine, or tangent? Tangent for TOA. So tangent of the angle, 7 degrees, is equal to opposite 18 over adjacent B. How do we solve a problem like this where the variable's hanging out in the denominator? Close. So we're not trying to break the 7 out of the angle. We have to get that B out of the denominator. So folks, with the inverse tangent, we use that when we're trying to solve for an angle. And we'll get to that on the next page. So goodbye to the B. And we get B tangent of 7 degrees equals 18. From here, we would divide by tangent 7. And now it's time to use our calculators. So again, folks, if you are borrowing one of my calculators, please make sure that the mode button, when you go to the 4th item down, is degrees and not radians. So typing in 18 divided by tangent of 7, we get 146.59. Is the 8 big enough to bump up my 9? It is. And what happens when we bump up 9 by 1? It turns into 10, so that's actually going to affect the 5 as well. So if I bump up 59, it changes to 60. So our final answer here, B equals 146.60. But as I've said previously, you don't have to write the 0. This isn't chemistry. We don't have significant digits, but just note that we have still rounded to 2 decimal places. It's just that second decimal place was a 0. Now that I know 2 of the 3 sides, what can I do to find the third? Pythagorean theorem. Now, someone in third block said, couldn't we also just use another trig ratio? Like, couldn't I do sine of 7 is opposite over hypotenuse? Absolutely. If that's easier for you, I mean, I tend to think Pythagorean theorem is a little bit easier just because we've seen it a lot more. But if you want to use another trig function to solve, by all means, go for it. I'm going to go ahead and show the Pythagorean theorem. So 18 squared plus my b value that I just found, the 146.6 squared, equals c squared. And if I square root all that stuff, so square root 18 squared plus 146.6 squared, we get 147.70. And yep, that third digit's a 0. That's not going to do anything. So it's 0.70, but we don't have to write that 0.7. Or we don't have to write the 0.70. We can just write 0.7. And we have now found all the missing pieces. So in these triangles, you'll always be given 3 and trying to solve for 3. There are 6 total things in a triangle, 3 angles, 3 sides, and you have to be given 3 of those things, 3 of those 6 things, to be able to solve for the other 3. Questions on that section? All right, let's turn the page. And on this page, we are going to find the measures of the missing angle, both A and B. You may want to look at your steps in the notes for this one, and those would be located on at the bottom, the top of page 2. So steps from notes, page 2. Whoops. And those steps are actually the same thing that we're going to be using for the story problems on this section as well. So we always start with the we always start with the angle, and then we try to determine the trig relationship. Now I'm going to go ahead and just start by trying to find A on all of these problems. So I'm going to mark A as my angle. And let's go ahead and do number 9 together, that tilted one. So we start with the angle. Our next step is to determine the side relationships. 4 is opposite. What's 11? Hypotenuse. Could we use the Pythagorean theorem? We could, but we actually don't need to here. We're not solving the triangle. We're just trying to find the 2 angles. So using this given information, what can I do to find A? What trig relationship do we have with O? So, ka, or toa, we've got so. So that means sine of the angle equals opposite 4 over hypotenuse 11. So what can be kind of confusing about sine, cosine, and tangent is they do represent a ratio, but we can also use them as an operation, similar to square roots. Yeah, they represent taking something to a fractional power, but we can also square root as an operation. So in a similar sense, we've got sine of A. How do we break A out of that sine function? This is where we inverse sine both sides. So if we have a variable trapped inside a trig function, that's where we use inverse sine, which is written as sine to the -1, but it's read as the inverse of sine. Cross those out. That breaks out the A, And then on your calculator, remember inverse sine is second sine. So second sine, that's how we get that sine to the -1. 4 divided by 11. And we get 21.32. 21.32 what? Degrees. Very good. So it's a good idea to still include your units when you can, especially in the story problems. Now that I have 2 of the 3 angles, do I need to do any fancy trick stuff to find the third one? Nope. So 2 out of the 3 sides, Pythagorean theorem. 2 out of the 3 angles, simply subtract from 180. So B will be 180 minus the 90 degrees minus the 21.32 degrees. So B is 68.68 degrees. So we only use inverse trig functions when we are trying to solve for an angle. Okay. We're going to go ahead and move to the bottom story problems. I want you to write units. Units are important for a couple of reasons. 1, we need to use the right units with our final answer. But 2, we need to make sure that the units in the problem are consistent with each other. So we'll go ahead and start with number 11 because it's kind of a weird problem. Wade likes to spy on his neighbors by attaching a GoPro to a kite and flying it over their fenced-in yards. If Wade always holds his kite at a 55-degree angle to the ground and his GoPro can film objects up to 120 feet above the ground, how many feet of string must Wade have in order to let his kite out far enough to effectively spy on his neighbors? Real world problems. So folks, let's try to draw out this diagram. So draw your prettiest kite. And there's the string of the kite. And the kite is making a 55-degree angle to the ground. So that 55-degree angle to the ground right here. We'll put the little ribbons on the kite string. There we go. So there's my kite. There's a little GoPro camera right there, I guess. So then, what else do we know? The GoPro can film objects up to 120 feet above the ground. That's an altitude or a straight up and down distance. So 120 feet straight up from the ground. And there's our right angle, and that's what makes this a right triangle. Huzzah. So now we have our diagram. Our next step is to figure out what the question wants us to find. It says, how many feet of string must Wade have in order to let his kite out far enough, yada, yada, yada. So we want the string length of the kite, which is going to be our hypotenuse. So following those steps from the notes again, we start with the angle, which is given. It's the 55 degrees. Then we label our side relationships. What's 120 relative to 55? Oops. And what about x relative to 55? Hype. So if we have O, we are going to use the sine trig function for so. So sine of the angle, 55 degrees, equals the opposite side, 120, over the hypotenuse side, x. See if you can solve this the rest of the way, rounding to the hundredths place. So we multiply both sides by x to move it out of the denominator. So x sine 55 equals 120. We divide by sine of 55. And using our calculator, 120 divided by sine of 55 gives us 146.49. The 2 is not enough to bump us up, so it stays at 146.49. What? Feet. That's our unit. Folks, do we have any questions on any of the parts of that problem with setting up the diagram or how we decided on a plan of action for solving? Alrighty then. I do want to go over number 13. Put a star by this problem. We're almost done, folks, and then I'm going to give you work time. So put a star by 13. We've got an airplane. Ooh, it's art time. Plane. Beautiful. It's flying 45 feet above the ground. That is an altitude or a straight from the ground perpendicular distance. So 4,500 feet. In its initial stages of descent. If the plane's slant distance is 4 miles. What's the problem with 4 miles? It's not in feet. So we've got the conversion factor there. So folks, how am I going to change 4 miles into feet? We're going to multiply it by the conversion factor, which is 5,280 feet per mile. And the reason why this conversion factor works is when I multiply these, the units of miles cross simplify, and I'm left with the feet unit that I want. So this gives me 21,120 feet. So that's why we have a star on this problem. That issue of units is kind of sketchy. So we have got miles, we need feet. So now for our hypotenuse, that slant distance, we are going to label as 21,120 feet. And when we connect those, there's our right triangle. Now what the problem is asking for is what is the angle of depression that the plane needs in order to land safely on the runway. So angle of depression, plane to runway, angle of elevation, which is easier to draw, runway to plane. So my angle of elevation from the runway to the plane would be this one. The angle of descent is always relative to a horizontal and would be this one. But again, that's not on our triangle diagram, and students sometimes will try to label this angle as the angle of depression. So I do recommend that anytime you have an angle of depression problem, change it into an angle of elevation problem by changing what's looking at what. So this is the angle we want to find, and we're going to call that theta. Same steps as before. We start with the angle. Our angle is theta. We labeled the side relationships. 4,500 is opposite to theta. 21,120 feet is hypotenuse to theta. So we have O. So our trig relationship will be sine. So sine of the angle equals opposite, 4,500 feet, over the hypotenuse, 21,120 feet. What do I do from here if we want to find theta? Inverse sine time. So sine to the negative 1. Goodbye, sine. Sine to the negative 1. Pew, pew. So then inverse sine 4,500 divided by 21, 120. We get 12.30. Yep, 2 is not enough to bump us up. So 12.30, or you can just write 12.3. 12.3 what? Degrees. Wonderful. I think we'll just go through one more problem and then you guys will have some work time. So that was all the first learning target. Kind of a lot of different things in that one. A little bit tougher because you kind of need to know your stuff of when to do what. So make sure if you haven't finished the homework packet problems that you do that so you can really get your bearing with this. On 9.2, even the story problems, we want all of the answers to be exact. What does that mean? No decimals. We want fractions and we want radicals. Now, you can use decimals to kind of like check yourself. If you want to use like the Pythagorean theorem to verify an identity or something, you can. But as far as the way you express your answers, simplified fractions and radicals. So we're going to go ahead and down by number 21, it's a story problem. Make sure you're showing units. And make sure you're drawing pictures or your diagram. And the only question on here that I want to look at is number 19. Because how we start special triangle problems is by identifying what special triangle we have. Now, if you're looking at this going, we're not given any of the angles, so how do we know it's 30, 60, 90 or 45, 45, 90? Because what are those mysterious two angles? What we are given is the side relationships. They tell us that x and x are the same. If this is x and this is x, this is an isosceles triangle. And in an isosceles triangle, if the legs are the same, the shoes are the same. Or the angles are the same. So if these sides are the same, those two angles are the same. So if this is 90 degrees, that leaves 90 degrees left for those two angles. If those two angles have to be exactly the same, 90 divided by 2 is 45. So boom, it's a 45, 45, 90 triangle. Go ahead and try that one on your own. See if you can label the side shortcuts and take it away. So we've got, for our side shortcuts, x is s, smallest side across from the smallest angle. That x is s, so that means 5 is s rad 2. So to solve that mini equation for s, we're going to divide both sides by radical 2. So 5 over radical 2 equals s. But the problem is we've got a radical in the denominator, so we're going to multiply by rad 2 over rad 2 to give me 5 rad 2 over 2. So that's what s is equal to, so that's what both of those x's are equal to. So 5 rad 2 over 2. Not 2.5 rad 2. Don't love that. And also not 5 halves with the rad 2 off to the side. So we want to write it all as one fraction, no decimals. Folks, that is it from me. You have the rest of the time to work. A question on that one?
Would you get it wrong if we put 2.5?
Because 2.5 is exact. I'd be more apt to accept that than this one because you can multiply those together. But since 2.5 is an exact decimal, it's okay, but we do kind of want to stick to the fraction form. All right, folks, any other questions? All right, use this time to work and ask questions.